Freeze drying explained. Common problems, how to avoid them. Intro. Freeze dryer, operating in a lab. Clean room. Freeze drying, also known as lyophilization, is one of the most powerful techniques used to preserve sensitive materials like pharmaceuticals, food, and biological samples. But while it's effective, it's not without its challenges. In this video, we'll explore what freeze drying is, how it works, and the common problems that can occur if it's not done right, plus how to avoid them. Freeze drying animation, or simplified process chart. Let's start with a quick overview of the freeze drying process. It begins with the freezing stage, where your product is frozen solid. Then comes primary drying, where ice is turned directly into vapor under a vacuum, a process called sublimation. Finally, secondary drying removes any leftover moisture to ensure long-term stability. Every stage requires precise control of pressure, temperature, and time. Visual. Lab technician loading vials into a freeze dryer. In a typical lyophilization setup, the steps are as follows. Loading. The freeze dryer is started, and once the desired loading temperature is reached, vials either filled or empty are loaded inside the chamber under sterile conditions. Freezing. The product transitions from a liquid to a solid. Proper freezing ensures a good structure during drying. Primary drying. The pressure is reduced and heat is applied, allowing ice to vaporize. Around 95% of the moisture is removed at this stage. Secondary drying. This step gets rid of any remaining water molecules. It begins right after the ice has been sublimated. Stoppering. Unloading. The vials are sealed inside the chamber and then removed after reaching the unloading temperature. Visual. Freeze dryer alarm, notifications, or technician checking the system. Now, let's talk about the common problems during freeze drying. Pre-freezing issues. Poor temperature control leads to uneven ice crystals, which causes bad drying. Primary drying problems. Uneven heat, vacuum leaks, or unstable shelf temperatures can stretch drying time and damage the product. Secondary drying challenges. Incomplete moisture removal can lead to product instability and shorter shelf life. Chemical, physical changes. Improper drying may change the texture, taste, or even the appearance of the product. Visual. Alarm icons, highlighted system errors. You may also run into equipment alarms and failures such as JIT, vacuum pump failure, JIT, pressure sensor malfunction, JIT, power loss. Conden, refrigeration or silicon heater failure. Condenser overload due to excess vapor, conden. Undersized condenser, conden. Incorrect shelf temperature setup. All of these can jeopardize your entier batch. Visual, preventive maintenance animation, training footage, SOP binders. So how do you prevent these issues? Regular maintenance and calibration. Well-trained personnel, accurate process controls, avoiding excessive shelf temperatures, never overloading the condenser. Using reliable sensors and automation systems. Remember, freeze drying is not fully automatic. You still need to monitor semi-automatic operations closely. Before and after product comparison, timeline showing drying efficiency. By addressing these problems, companies can achieve better product quality, longer shelf life, fewer batch failures, and lower production costs. Visual. Clips showing advanced freeze dryers, software, and touchscreens. The future of freeze drying is evolving fast. New equipment designs, better automation, and more energy-efficient systems are making processes smarter and more reliable. Conclusion. Smiling technician, successful freeze-dried products. To wrap it up, freeze drying is a powerful preservation method, but only when done right. By understanding the stages, watching for issues, and applying preventive strategies, you can ensure consistently high-quality results. FAQs. What is the purpose of freeze drying? To remove moisture from sensitive materials while keeping their structure intact. How is it different from traditional drying? Freeze drying works at low temperatures under vacuum, preserving quality better. Can all products be freeze-dried? It's best for items like food, pharma products, and biological samples. How do I know my process is efficient? Check drying time, product quality, and system performance regularly. Is freeze drying eco-friendly? It can be energy intensive, but newer systems are more sustainable.